Welcome to Variance and Standard Deviation. We're looking at population, variance, and standard deviation. This happens to correspond with section 13J from the core mathematics book. If you're in Haese and Harris, analysis and approaches, this corresponds with 13J. So we're looking at how to find the variance of a set and how to find the standard deviation of a data set. So variance is a measure of spread, and what we want to see is how spread out the data is. But what happens is if we start taking each value and we see how far each value is from the mean. So that's this little component here, x sub I minus mu. That means how far is each value from the mean? Well, what happens is if we add all those up, the ones that are above the mean would have positive values, and the ones that were below the mean would end up being negative. And if we add them all up, we'd end up with 0, and then that's not useful. So in order to make this a useful piece of information, if we square each of those values, then we would be adding up only positive values, which is actually going to give us something then that we can measure. So we're going to square each of those, and then we're going to add them up. We don't know how many data values we have, so we just denote that with an n, and so we have to add them all up, and then we're using sigma notation that we're adding them up from I equals 1 to n. And then we're going to divide that to find an average, so we're going to divide that by how many numbers were in the set, which is n. That is the formula to find the variance of a population. However, since I squared distances from the mean, or the distances from the mean, since I squared that, then the unit is off on this measurement. In order to fix that, we find the standard deviation by taking the square root of that whole component there. So I would find the variance first and then take the square root. Notice this is of the top and bottom here of the variance. And I'm going to call the standard deviation sigma. This is a lowercase Greek letter sigma, which means the variance is going to be sigma squared. Standard deviation is considered a non-resistant measure of spread and is only useful when the data is approximately symmetrical. To calculate this on a calculator, which you'll definitely need to do, if you have a TI-84, you would calculate this by finding the stat button and then hitting enter on edit. And you could put all of your data into L1. Once you've done that, then back from the home screen, you can find the stat command again and hit the right arrow key once to go to where it's asking you to calculate something in that tab. And you would choose one variable, statistics. When you do that, you'll see something that comes up like the image on the board, and it'll have sigma x and it'll have s sub x. I believe on your calculators the s is above the sigma, but don't quote me on that. S would be the standard deviation if you were working with a sample. The formula is slightly higher, or the answer ends up being slightly higher because instead of dividing by n, you're going to divide by n minus 1 for that. You'll see that if you get into more of a statistics course. But in this course, we will only be considering the standard deviation of what would be considered the entire population, so you do not need to ever concern yourself with the one that says S sub x or S of x. We're only going to be looking at the sigma. All right, so let's practice by hand first, computing the variance and standard deviation of this set, and then we can check that with the calculator. For the variance, first thing I need to do is find what the average is. So I'm going to add up 2 plus 4 plus 4 plus 6 plus 7 plus 10. So that would be 33, and I'm going to divide by the number of values. 33/6, which would be 5.5. So I want to see how far is each value from 5.5 and then square that. So 2 minus 5.5 squared plus 4 minus 5.5 squared plus another 4 minus 5.5 squared plus 6 minus 5.5 quantity squared plus 7 minus 5.5 quantity squared plus 10 minus 5.5 quantity squared. And now that I've seen how far each one is, I've squared each one, I've added them all up, I would divide by 6 since I had 6 values here. So this would be my formula for the variance. If we actually had to compute this without calculator, then I would probably change the 5.5 to fraction form once I've subtracted. I would change these to fraction form to allow me to square them a little bit easier. So 2 minus 5.5 would be negative 3.5, which would be negative 7 halves. And if I square that, I would get 49 fourths. Similarly, negative 3 halves squared would be 9 fourths, and another 9 fourths. 1 half squared would just be 1/4, and then 3 halves squared, 9 fourths, and then 4.5, which would be 9 halves squared, would be 81 fourths, and then I would be dividing that whole thing by 6. So let's go ahead and add these up, see what we get. Add across the numerators, 49 plus 9 plus 9 plus 1 plus 9 plus 81. 158 divided by 4 and then divided by 6. So 158 over 24. That reduces to 79 twelfths, which is approximately 6.583 to 3 sig figs, which is what the IB curriculum is asking you for. That would be 6.58 for that variance. That would mean that the standard deviation, go from your original value where you kept all your decimal points, and that would mean that the standard deviation of this set would be approximately 2.565800, etc., but to 3 sig figs, 2.57. Then, in the calculator, we can go to Stat, Edit, and enter these values in L1, and then go to Stat, Calculate, and if you check, hopefully, you'll see that the sigma x is also to 3 sig figs, 2.57. The calculator does not tell you the variance in that command, so you would actually need to take the standard deviation and just square it yourself if you were asked to find the variance. So I have for you 4 different sets here. If you want to pause the video, up to you. But think about which of these sets would have the least variance, which of these sets would have the most variance, and see if you can rank them. If you've thought about that now, hopefully, let's go ahead and start discussing. So, and by discuss, I mean I'll talk to you. The set that has all 5s, well, the mean of that set would be 5, and each of these numbers varies none from that mean, so the variance here is simply 0. That would definitely have the least variance then if I'm ordering these from the least to the greatest. In the next one, the mean is also 5, but they would vary by 2, by 1, by 1, and by 2. I'm not concerned with the direction, so I'm just saying what the distance is since I'm going to square them anyways. So I would have 4 plus 1 plus 0 plus 1 plus 4, and then I would divide that by 5. So this set would have a variance of 2. In set C, they would vary by 4, 2, 2, and 4. So I would have 16 plus 4 plus 0 plus 4 plus 16 divided by the 5. This set would have a variance of 8. And then in set D, the mean is also 5. They vary by 4 and then 0, 0, 0, and 4. So that would be 16 plus 0 plus 0 plus 0 plus 16 divided by 5, giving us a variance of 32/5, which is 6.4. So if we were ranking these from the least to the greatest, this would be from A, B, D, C. So I hope you got that right. And hopefully you're thinking through some of those so that you could investigate sets and potentially be able to rank the variances or the deviations of those sets without actually having to calculate all of those values. The last thing that we need to talk about with the variance and standard deviation is, can we find the variance and standard deviation from a frequency table, or if we had grouped data, can we find the variance and standard deviation? So from our original frequency table of devices, the original data is the box that's in the center, and on the left side here I have the frequency table that I used at the beginning of the video. From a frequency table, instead of writing out each data point, especially if you have many, many data points, instead of writing out each value, you can simply take, once you've found the mean of your data set, you can simply take and subtract the data value from the mean, square that, and then multiply by that data value's frequency. So for the set on the left, well, either set of data, but the set that's on the left that's grouped into the frequency tables, I know that the average, which I can call bar x or I can call mu, that average is 11.16, repeating on the 6. And so if I'm not going to set the whole thing up for you, but I can start setting it up, that for instance, I would have 11.16 repeating as my mu. I would say 4 devices minus the average of 11.16 repeating, and then I would square that distance, and I'm going to multiply that by 1 because that only had a frequency of 1. And then I would take 7 devices and subtract mu. I would square that, and then instead of doing that 2 more times, I'm just going to go ahead and multiply that by 3 because that 3 was my frequency of that value. Similarly, we would do the rest, and then when we got to the end, I would say 15 minus 11.16 repeating, square that, and then multiply it by its frequency, which was 4. And when I divide, I'm going to be dividing by the total number of frequencies, which is 24 in this case. The formula that you're going to see here is that I'm going to take the frequency of the value and multiply it by the data value minus mu, quantity squared. Then I'm going to add all those up, so this should look pretty familiar. I'm going to add them up from 1 to n, however many data values I have. Oops, sorry, that should be an I. I don't want duplicity in my indices here. In this case, n is not necessarily the total number of data values that I have, because n is going to be the number of devices here. Since they each have their frequencies, that means I would only have or n here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different terms in that numerator. So n is not actually 24 in this case, but n is 10 since I had 10 different distinct values. And then I need to divide that by the total frequency. Well, the total of all of the frequencies is going to just be represented by the sum from I equals 1 to n of f sub I. So that would be the total of the frequencies, which in this case would be the 24. So that's how we would do it from if we had a frequency table. In the calculator, you can simply enter your frequencies in L2, and then when you go to calculate your one variable stats, you would choose, for your X list, you would choose L1, and then where it asks you what your frequency list is, instead of leaving that blank, you would choose L2 by hitting second and then the number 2, and then that tells it that you're working with a frequency table, and then you would read your one variable stats as usual. Lastly, if I have grouped data, I won't be able to find the exact variance or deviation, because I wouldn't have enough specific information about the raw data values. Instead, if I had categories here for the number of devices and frequencies, as you can see from the table on the right, then I would use the midpoint value in each interval, and I would assume that all of the frequencies in that category take on that midpoint value. For instance, for the number of devices for 4 to 6, the midpoint value of that interval is 5. So I would consider that 5 devices with a frequency of 1. I would consider 8 devices would have a frequency of 8. So there were 8 students that had 8 devices, we would say. There would be 4 students that had 11 devices. So this does change the data set some, right? Because it would say, it would just have 5, 8, 8, 8, 8, 8, 8, 8, 8, 11, 11, 11, 11, right, etc. And so because of that, it's not going to be the exact same number. It's going to change that a little bit, but we would use these mid-interval values along with the frequencies, and then we would use the L1 and L2 like I showed you from the left here. So hope that helps you on your variance and standard deviation. Have fun doing your math.